The third day of the ISMAR conference. The session title is Learning and Training. And my name is Haruo Takemura from Osaka University, and I'm a session chair for this Learning and Training session. We have 6 paper presentations. 2 of them are TVCG papers, and 4 of them are ISMAR paper. So let me introduce the first speaker. She's Mahesha Varasinghe, and she's going to present about VocabulARy, learning vocabulary in AR supported by keywords visualizations. Okay. Please start.
Okay, thank you, Professor. Good morning, everyone. I'm Mahesha Varasinghe, and today I'm going to talk about our project, VocabulARy, learning vocabulary in AR supported by keyword visualization. First, I would like to thank all my co-authors. 3 of them are also already here in this audience. And the takeaway message of this talk would be learning vocabulary using these keyword visualizations. I assume that you all have seen this book at one point of your life, especially when you are a beginner for learning a language. As you can see, all these books have some sort of visual representations of objects which are related to the new words that you are trying to learn. So rather than having these pictures and text on books to learn new words, what would happen if we make the world around us a book itself that we could read? For example, we could physically label the objects in our environment to learn new words that also have the direct link to the situation and the context. But can we physically label everything around us? For example, assume that you need to learn part of the human body. Can we physically label them? It's not quite practical, right? So what would be the best way to make the world around us a book to read in an interactive manner? Rather than using physical labels, we can use digitally overlaid labels that can be generated by technologies like augmented reality. And also, this digital representation can easily expand when you want to learn another foreign language. Apart from showing the new words in the context, there are many more techniques for enhancing the vocabulary learning process. Keyword method is one of such effective methods when you can create a symbolic link between new and prior knowledge using associations triggered by keyword. In other words, you can connect the sound of a word you want to learn to a word that you already know in either your first or target language. Through this process, you can create a mental image that helps you to remember the association. For example, the Japanese word for apple is ringo, which is in English sound like ring and go. As you can see here, this ringo can be imagined as a ring is going for a walk, holding hand with apple. Like this, we can create these mental images. So we thought that it would be really interesting to see what would happen if we incorporate this keyword method to a context-based AR vocabulary learning environment. So in our research, first we categorized previous work, which have been done for AR-supported vocabulary learning. Despite the fact that prior work looked at AR for vocabulary learning, discovering several benefits such as better improved retention, high enjoyment, motivation, and engagement, none provide a direct comparison of AR application that runs on a head-mounted display to the same runs on non-AR interface. And also, we couldn't find any vocabulary learning AR application that combines keyword include visualization. So we believe that those comparisons would help us to answer these questions. Is there a significant effect of real-world context in vocabulary learning scenarios? Can animated visualization of keywords help to enhance vocabulary learning? In order to answer this question, we developed two prototype systems for vocabulary learning. One is on an AR head-mounted display, and the other one on an Android tablet device. Both AR and non-AR systems combine the keyword method with physical object. With the AR head-mounted display, users can look around the physical environment or a physical room where certain objects are labeled with a button indicating that their translation is available. In the non-AR condition, users can see an image of the same physical room where also the objects on the image are labeled with buttons. As you can see here, in the AR keyword method condition, when a user clicks a button with a hand gesture, the English and Japanese word as well as a keyword appears. In the AR keyword plus visualization condition, apart from the English-Japanese word and the keyword, an additional visualization of the keyword also appears. As same as in the AR keyword method condition, in the non-AR keyword method condition, when user click a button on the image, the keyword appears with the English and Japanese word. And in the non-AR keyword plus visualization condition, an additional visualization of the keyword also appears. Here you can see the study design of our work, which has considered the interface as the between subject factor and the instruction mode as the within subject factor. In order to find out more detail about the complete design of this study, please read our vocabulary paper. So in our study, we have two independent variables, the interface, which is either AR or non-AR conditions, and the instruction mode, which is keyword or keyword plus visualization condition. Each independent variable was evaluated against multiple dependent variables, such as recall, mental effort, and efficiency. Because of the time limitations, we only present some selected results of our evaluation. First, we present results for the participants' immediate recall performances. There, our results show a significant main effect of interface on immediate recall performances, where participants' immediate recall scores are significantly better in AR condition compared to the non-AR condition. For the instruction mode also, our results show a significant main effect on immediate recall, where participants' scores in keyword plus visualization is significantly better than in only keyword method. We also present results for participants' delayed recall performances, which we conducted after 7 days of the study. There, our results do not show any significant main effect between interfaces on delayed recall performances, which we measured after 7 days. However, for the instruction mode, our results show a significant effect on delayed recall performances, where participants' scores in keyword plus visualization are significantly better than in only keyword method. Then we present results for the participants' mental effort. Our results also show a significant main effect on interface on participants' mental effort, where mental effort is significantly lower in AR condition compared to the non-AR condition. For the instruction mode also, our results show a significant main effect on participants' mental effort, where in keyword plus visualization method, significantly lower than the only keyword method. Finally, we present results for the participants' immediate efficiency. We also calculated this immediate recall efficiency of the participant, considering their immediate recall performances and mental effort matrices. For more information, you can also find the equations and everything that we use to calculate these learning efficiencies. There we can see that keyword plus visualization efficiency for both AR and non-AR interfaces are higher than only keyword method. And again, please read our paper to find out all the results of our research. And In conclusion, our results indicated that AR outperformed the non-AR system regarding immediate recall performances, mental effort, and task completion time. Additionally, the visualization approach scored significantly higher than only showing the written keyword with respect to all the dependent variables. And also, visualization of keyword proved more efficient compared with the traditional keyword-only method. At the end, we believe that finding of this study may enable new directions for future improvements in AR-enabled vocabulary learning systems. Before finishing my presentation, again, I would like to thank all the co-authors of this paper. And then you can find the full vocabulary paper through this QR code. And thank you so much for listening.
Thank you very much. Thank you very much for the presentation. Are there any questions or comments from the